What if the energy to power advanced alien spacecraft wasn't some far-fetched sci-fi concept, but something hiding in plain sight, woven into the very fabric of the universe? Picture this, a glowing orb hovering silently over a desert, defying gravity without exhaust trails or conventional fuel. Witnesses describe an eerie hum, like the air itself is vibrating. Strange, right? But here's the thing: scientists have long theorized that empty space isn't really empty at all. It's teeming with infinite energy, fluctuations so small they're almost imperceptible, yet powerful enough to theoretically bend the laws of physics. This is zero-point energy, and it might just hold the key to unlocking the mysteries behind UFO propulsion. Think about the most baffling UFO encounters: crafts making sharp 90-degree turns at impossible speeds, or hovering motionless for hours without a sound. These aren't just random anomalies. They could be evidence of a technology harnessing energy from the vacuum of space itself. Imagine tapping into an endless power source, one that doesn't require fuel rods, solar panels, or combustion. That's the promise of zero-point energy, and if extraterrestrial civilizations have mastered it, it would explain so much, from sudden accelerations that defy inertia to sightings near geomagnetic hotspots. The clues are piling up. But how does it work? Why would aliens use these energy zones, and where might they exist on Earth? The answers could rewrite everything we know about physics and our place in the cosmos. Over the next few minutes, we're diving deep into the science, the sightings, and the startling connections between zero-point energy and unexplained aerial phenomena. This isn't just about UFOs, it's about uncovering a hidden layer of reality, one that might already be powering visitors from beyond our world. Strap in, because what you're about to discover will challenge everything you thought was possible. To understand zero-point energy, we have to step into the bizarre world of quantum mechanics, where the rules of classical physics break down. Even in a vacuum, what we think of as completely empty space particles flicker in and out of existence in a ceaseless dance. These fleeting fluctuations mean that space is never truly empty. It's a seething ocean of potential energy, always active, even at absolute zero temperature. That's why scientists call this phenomenon zero-point energy. It represents the baseline hum of the universe, the irreducible energy that remains when all other sources are stripped away. What makes this so mind-bending is that this energy isn't just theoretical. We've observed its effects in real-world experiments like the Casimir Effect, where two uncharged metal plates placed incredibly close together in a vacuum are pushed together by the sheer pressure of these quantum fluctuations. It's as if the invisible energy of nothingness has tangible force, proof that the vacuum of space isn't passive. Now, imagine a civilization advanced enough to tap into this endless reservoir, to extract usable power from the very fabric of reality. For an alien species that has cracked this puzzle, the implications would be staggering. Traditional propulsion systems, rockets, jet engines, even theoretical fusion drives require fuel, emitting heat, light, or exhaust. But a craft powered by zero-point energy could operate silently, without burning anything, bending space-time itself to move. This would explain those baffling UFO sightings, sudden accelerations without sonic booms, hovering without visible means of lift, maneuvers that defy our understanding of inertia. It's not magic, it's physics beyond our current grasp. The challenge for us: this energy exists at scales so small, so ephemeral, that capturing and directing it would require technology far beyond anything we've dreamed of. Yet, if another civilization has mastered it, the universe might be buzzing with ships we can barely comprehend. The story of zero-point energy begins not in the world of UFO sightings, but in the quiet laboratories of quantum physics pioneers. At the dawn of the 20th century, Max Planck first theorized that even at absolute zero, the coldest possible temperature where all classical motion should cease, a mysterious residual energy still thrived. This revolutionary idea shattered conventional thinking, suggesting the universe itself vibrates with an unseen hum. Planck's discovery laid the groundwork for quantum mechanics, but it would take decades for scientists to grasp the full implications. That this zero-point energy wasn't just a mathematical quirk, but a fundamental property of reality. By the 1930s, physicists like Werner Heisenberg and Erwin Schrödinger had uncovered even stranger truths. Their equations showed that empty space isn't empty at all. It's a turbulent sea of virtual particles blinking in and out of existence. These fleeting disturbances carry real energy, enough to theoretically power entire civilizations if harnessed. But the real breakthrough came in 1948, when Dutch physicist Hendrik Casimir proved it experimentally. His famous experiment placed two uncharged metal plates mere nanometers apart in a vacuum. Against all expectations, they were pushed together by an invisible force, the pressure of zero-point energy itself. For the first time, science had physical evidence that nothingness could exert power. Now, here's where it gets eerily compelling. Around the same time Casimir published his findings, reports of bizarre aerial phenomena began surging. Witnesses described glowing disks performing maneuvers that defied known physics: sudden stops, right-angle turns, accelerations faster than any human pilot could survive. Coincidence, maybe, but consider this. Many of these sightings clustered near geological fault lines, volcanic regions, and places with unusual electromagnetic activity, areas where Earth's natural energy fields interact intensely with the environment. Could these locations act as natural hotspots for accessing zero-point energy? The parallels only deepen with time. In the 1960s, physicist Robert Forward explored zero-point energy's potential for propulsion, even publishing papers on how it might enable anti-gravity effects, ideas that sound ripped from UFO reports. Meanwhile, declassified government documents reveal military interest in these theories as early as the Cold War. One declassified memo from 1966 specifically mentions electrogravitics research, noting its potential to explain anomalous aerial objects. The timing is impossible to ignore. As our understanding of vacuum energy grew, so did encounters with crafts that seemed to operate by its rules. Fast forward to today, where cutting-edge experiments continue to blur the line between science fiction and science fact. Quantum physicists now manipulate zero-point fluctuations in labs using superconductors and nanostructures. NASA has even funded studies on quantum vacuum plasma thrusters, engines that theoretically tap into this energy. Yet for all our progress, the mystery remains. If humanity is just beginning to scratch the surface of this technology, who or what might have already mastered it? The answer could rewrite history and our place in the cosmos. From Planck's chalkboard equations to the glowing orbs in our skies, the thread connecting zero-point energy to UFOs isn't just speculative, it's woven into the fabric of modern physics. Every unexplained maneuver, every silent hover, every account of crafts drawing power from thin air points toward a startling possibility that we're witnessing not just visitors from another world, but the applied science of a civilization that cracked the universe's energy code long before we even knew it existed. The Casimir Effect isn't just a curious laboratory trick, it's one of the most direct pieces of evidence we have that empty space is anything but empty. Picture two thin, uncharged metal plates placed so close together in a vacuum that the gap between them is narrower than a single strand of human hair. According to classical physics, nothing should happen, but in reality, an invisible force pushes the plates together. Why? Because the space outside the plates is filled with a storm of quantum fluctuations, particles and waves popping in and out of existence, while the narrow gap between the plates restricts which fluctuations can exist there. The result, a pressure differential strong enough to move physical objects, proving that the empty vacuum is alive with energy. This phenomenon is more than just a scientific oddity. It's a blueprint for how zero-point energy could be harnessed. If quantum fluctuations can exert measurable force on something as small as metal plates, imagine what they could do if amplified or directed on a larger scale. Advanced civilizations might not just observe these effects, they could engineer ways to control them. Think of it like the difference between feeling the breeze and building a wind turbine. One is passive, the other transforms energy into usable power. For a species with the right knowledge, manipulating the quantum vacuum could mean creating propulsion systems that don't rely on combustion or ejection mass, but instead ride the natural currents of spacetime itself. Now consider how this scales up. The energy between the Casimir plates is minuscule, but quantum fluctuations exist everywhere, permeating the entire universe. If an alien civilization found a way to create artificial gaps or structures in spacetime, perhaps using materials or fields we haven't discovered yet, they could theoretically amplify this effect. Instead of two plates nanometers apart, picture an entire spacecraft enveloped in a field that selectively blocks or enhances quantum fluctuations around it. The resulting imbalance could generate thrust without fuel, explaining how UFOs might hover silently or accelerate instantaneously. There'd be no fiery exhaust, no roaring engines, just the subtle hum of the universe's hidden energy being tapped. The real challenge isn't whether zero-point energy exists. We know it does, but how to bridge the gap between laboratory-scale effects and practical technology. Human scientists are already exploring ways to manipulate these forces, from advanced nanomaterials to high-temperature superconductors. Yet even our most ambitious experiments barely scratch the surface. Compare that to UFO sightings where crafts exhibit control over inertia and gravity, performing maneuvers that would require energy densities far beyond anything we can produce. The implication is staggering. If these objects are real, their creators have likely mastered physics in ways we're only beginning to theorize. What makes the Casimir effect so compelling isn't just the science, it's the timing. The same decade this phenomenon was confirmed, reports of disc-shaped objects performing impossible aerial feats began circulating globally. Witnesses described crafts that defied wind resistance, changed direction without slowing down, and hovered without sound or exhaust behaviors that align eerily with what zero-point propulsion might look like. Coincidence, perhaps, but when you piece together the quantum physics with the close encounters, a pattern emerges. The universe's hidden energy might not be so hidden to everyone. For us, it's a frontier of science. For them, it could be the foundation of an entire technology. When we see a modern jet engine roar to life, it follows a principle we've understood for over a century: burn fuel, create thrust. But UFOs don't play by those rules. Witnesses describe crafts accelerating from 0 to thousands of miles per hour in an instant, making hairpin turns without slowing down or hovering silently for hours, all without exhaust trails or the deafening noise we associate with propulsion. These aren't just engineering marvels, they're violations of known physics, hinting at a power source fundamentally different from anything humans have invented. One theory that could explain these capabilities is electromagnetic propulsion, where powerful fields manipulate the surrounding space to generate movement. Think of it like surfing on invisible waves of energy rather than pushing against air or expelling fuel. Some declassified military reports even describe UFOs emitting strange glows, often pulsating in rhythmic patterns, suggesting they might be surrounded by intense electromagnetic fields. But here's the catch: generating that kind of energy with human technology would require power plants the size of cities. Yet these crafts appear compact, even nimble, implying they've tapped into something far more efficient, like zero-point energy. Compare that to our most advanced propulsion concepts. Ion thrusters used in satellites are incredibly fuel-efficient but produce weak acceleration. Nuclear thermal rockets, still in development, offer more power but come with radioactive risks and massive weight. Even theoretical antimatter engines, the holy grail of human spaceflight, would require staggering amounts of fuel production to be practical. Now imagine a craft that needs no fuel at all, one that draws energy from the vacuum of space itself. That's the promise of zero-point propulsion, and it would render every human propulsion method obsolete overnight. The differences go deeper than efficiency. Conventional engines follow Newton's third law. For every action, there's an equal and opposite reaction. Rockets push exhaust downward to go upward. But UFOs don't seem to obey this rule. They move without any visible reaction. Some physicists speculate they might be manipulating inertia itself, effectively slipping through space-time rather than pushing against it. This aligns eerily with quantum vacuum theories, where fluctuations in empty space could be harnessed to create localized distortions, like surfing a wave without needing to paddle. Then there's the sound, or rather, the lack of it. Jet engines thunder because they're ripping apart molecules to create thrust. Even futuristic fusion drives would likely produce some noise from plasma vibrations. Yet countless UFO reports mention an unsettling silence, broken only by a faint hum or buzzing. That matches zero-point energy models, where propulsion wouldn't involve explosive reactions but subtle manipulations of quantum fields. No combustion means no sound, just the whisper of space-time itself being tuned like an instrument. Perhaps the most telling clue lies in the heat signatures, or the absence of them. Our fastest aircraft, like the SR-71 Blackbird, heat up to nearly 600 degrees from air friction at high speeds, but infrared scans of UFOs often show no thermal buildup, as if they're not interacting with the atmosphere at all. This defies known aerodynamics unless they're somehow shielding themselves with a field that reduces friction to zero, another trick zero-point energy might enable by bending the fabric of space-time around the craft. So what does this mean for the UFO mystery? If even a fraction of these sightings are real, we're not just looking at advanced technology, we're looking at a complete paradigm shift in physics. Human propulsion methods are all about force, resistance, and energy conversion. But zero-point propulsion would operate on an entirely different principle: harmony with the universe's hidden energy. It's the difference between rowing a boat and teleporting. One follows the rules, the other rewrites them. And if that's what we're witnessing in our skies, the implications stretch far beyond unidentified flying objects. They hint at a science we're only beginning to glimpse. The sheer efficiency of UFO propulsion systems doesn't just bend the rules, it shatters them. Consider the eyewitness accounts: crafts accelerating from standstill to hypersonic speeds without sonic booms, hovering effortlessly for hours without refueling, executing maneuvers that would rip human-made aircraft apart. These aren't incremental improvements over our technology. They represent a quantum leap, one that suggests a power source operating on principles we're only beginning to grasp. Zero-point energy fits this profile perfectly, offering theoretical solutions to every baffling behavior we've observed. Take sudden acceleration, for instance. Conventional rockets rely on burning fuel, which means their thrust is limited by how much mass they can carry and how quickly they can expel it. But a craft tapping into the quantum vacuum wouldn't face those constraints. Instead of carrying fuel, it could manipulate the fabric of spacetime itself, creating localized distortions that propel it forward. This would explain how UFOs achieve instant acceleration without visible exhaust. They're not pushing against anything in the traditional sense. Think of it like a surfer catching a wave. The energy comes from the ocean, not the surfer's muscles. In this case, the ocean is the seething quantum foam of empty space. Silent operation is another telltale sign. Combustion engines roar because they're literally exploding fuel to generate thrust. Even our quietest electric drones produce audible whirring from their propellers. Yet UFOs often glide through the air with nothing more than a faint hum, something witnesses compare to the buzz of a transformer or the vibration of a tuning fork. Zero-point energy interactions would naturally produce this effect, since the propulsion system wouldn't involve moving parts or chemical reactions. The only sound might come from residual electromagnetic vibrations, like the quiet resonance of a struck crystal bowl. Then there's the complete absence of exhaust trails. Jet engines leave behind visible plumes because they're heating and expelling air along with combustion byproducts. But if a craft is drawing energy directly from the quantum vacuum, there's nothing to burn, nothing to eject. It's not leaving a trail because it's not throwing anything away. Every joule of energy gets harnessed and recycled. This efficiency would be revolutionary for interstellar travel. Human spacecraft waste enormous amounts of energy lugging fuel around, creating a vicious cycle where more fuel is needed to carry the fuel itself. A zero-point propulsion system sidesteps this entirely, turning the entire universe into its fuel tank. Interstellar distances become far less daunting with this kind of technology. Our fastest probes would take tens of thousands of years to reach the nearest stars, but a craft powered by vacuum energy could theoretically sustain acceleration indefinitely without refueling. Even more intriguing is how this might enable maneuvers that seem impossible to us, like inertial dampening. UFOs routinely make right-angle turns at thousands of miles per hour, a move that would turn human pilots into paste due to G-forces. But if the craft can manipulate the quantum fields around it, it might effectively disconnect from inertia locally, allowing it to change direction without crushing its occupants. The implications for an advanced civilization are staggering. With zero-point energy, the universe transforms from a vast, empty desert into a network of accessible pathways. Suddenly, crossing light years becomes as routine as we consider cross-continental flights. Energy scarcity disappears every point in space teams with unlimited power waiting to be tapped. This could explain why some UFOs show no concern for endurance. They're drawing from an inexhaustible source, making pit stops or supply chains obsolete. Humanity's current energy struggles highlight just how transformative this would be. We burn fossil fuels, split atoms, and harness sunlight, all while dealing with waste, pollution, and diminishing returns. A civilization using zero-point energy would operate on an entirely different plane, free from these limitations. Their technology wouldn't just be better, it would be fundamentally different in kind, explaining why UFO encounters feel less like encountering advanced aircraft and more like witnessing magic. But as Arthur C. Clarke famously noted, any sufficiently advanced technology is indistinguishable from magic. In this case, the magic might simply be mastery over the universe's hidden energy. This isn't just about solving the UFO mystery, it's a glimpse into humanity's possible future. If zero-point propulsion is real, it represents more than an alien technology. It's a roadmap for our own evolution. The same quantum phenomena being studied in labs today could one day power our starships. Until then, the UFOs in our skies may be showing us what's possible when a species unlocks the deepest secrets of the cosmos, not through wishful thinking, but through physics we're only beginning to understand. Whispers of government involvement in zero-point energy research have circulated for decades, but declassified documents and insider testimonies now paint a far more intriguing picture. In 2017, the Pentagon officially confirmed the existence of the Advanced Aerospace Threat Identification Program, ATIP, a secretive initiative that studied UFO encounters and their potential propulsion technologies. Among its most explosive revelations, a trove of technical papers examining advanced energy concepts, including methods to extract energy from the quantum vacuum. These weren't fringe theories, they were serious investigations funded by the U.S. Department of Defense, exploring technologies that could redefine physics as we know it. Former intelligence officer Luis Elizondo, who headed ATIP, has openly stated that some observed UFO maneuvers appear to defy our current understanding of aerodynamics and propulsion. But here's what's even more telling: declassified OTIP slides reference space-time metric engineering and warp drive mechanics, concepts deeply tied to zero-point energy theories. One leaked document discusses harnessing vacuum fluctuations to achieve mass reduction, a breakthrough that would allow aircraft to effectively neutralize inertia, precisely the behavior witnesses describe in UFO encounters. The implications are staggering. Military scientists may have been reverse engineering principles that extraterrestrial crafts already mastered. The trail doesn't stop there. Decades before OTIP, projects like the U.S. Air Force's 1956 Project Silver Bug studied saucer-shaped aircraft with field propulsion systems designs suspiciously similar to UFO reports. Recently declassified Canadian archives reveal that their military scientists investigated electrogravitics in the 1950s, explicitly linking it to unexplained aerial phenomena. Even Nazi Germany's infamous Bell device, according to declassified OSS files, allegedly experimented with vacuum energy extraction. These aren't isolated incidents. They form a pattern of state-sponsored research into technologies that eerily align with zero-point physics. Perhaps most compelling are the whistleblowers. Physicist Dr. Hal Puthoff, who consulted for both OTIP and earlier government programs, has published peer-reviewed papers on zero-point energy's potential. In a 2015 interview, he hinted that certain classified findings validated aspects of quantum vacuum propulsion. Then there's aerospace engineer Boyd Bushman, a former Lockheed Martin scientist who claimed before his death that U.S. defense contractors had replicated anti-gravity tech based on manipulating quantum fields. While skeptics dismiss such accounts, the consistency between these testimonies and declassified documents is hard to ignore. The global dimension adds another layer. Russia's state-run TV has aired segments on energy from the vacuum, while China's 2020 white paper on aerospace innovation lists quantum propulsion as a strategic priority. French military archives from the 1970s contain radar data of UFOs performing maneuvers that physicists later modeled as zero-point driven. Even the Vatican's chief astronomer, in a little-known 2011 lecture, suggested that advanced extraterrestrial civilizations might use vacuum energy manipulation for interstellar travel. What emerges isn't a conspiracy theory, but a documented multinational pursuit of science that could explain the UFO enigma. The pieces fit together too neatly. Military programs investigating exotic propulsion, whistleblowers describing technologies that mirror quantum physics, and UFO behaviors that align with zero-point energy models. This isn't about little green men, it's about a potential energy revolution hiding in plain sight, one that governments have quietly chased for generations. The question isn't whether zero-point energy is real, we know it is. The real mystery is how close we or someone else might be to harnessing it. The pyramids of Giza stand as silent sentinels of a mystery we've yet to fully unravel. Built with precision that rivals modern engineering, these ancient structures align perfectly with celestial events and exhibit mathematical properties that hint at knowledge far beyond what we'd expect from Bronze Age societies. But what if their true purpose wasn't just as tombs or monuments, but as energy devices? A growing number of researchers propose that the Great Pyramid's design, with its granite chambers and intricate shafts, might have functioned as a resonator for harnessing natural energy fields, possibly even tapping into the same quantum fluctuations we now call zero-point energy. Consider the strange acoustic properties found inside the pyramid's chambers. Experiments reveal that certain frequencies resonate powerfully within its structure, creating standing waves that could theoretically interact with the quantum vacuum. Ancient Egyptian texts speak of the pyramid as a machine, with inscriptions referencing a mysterious energy called Ankh, described not just as life force but as something that could be channeled. Could this be a coded understanding of vacuum energy? The idea isn't as far-fetched as it sounds. Modern studies show that pyramid shapes can focus electromagnetic energy into their center, and some theoretical models suggest they might even amplify scalar waves, a potential key to zero-point extraction. Then there's the Baghdad Battery, a 2,000-year-old artifact discovered in modern-day Iraq. Clay pots with copper cylinders and iron rods filled with acidic residue resemble primitive electrochemical cells. Mainstream archaeology dismisses them as storage vessels, but reconstructions prove they can generate measurable electricity. If ancient cultures were experimenting with energy storage, is it so unbelievable they might have stumbled upon greater secrets? The Vedic texts of India describe Vimana's flying machines powered by mercury vortex engines, a technology eerily similar to modern theories of spinning superconductors tapping zero-point energy. Sanskrit verses even detail propulsion systems that ride the waves of the cosmos, avoiding friction by manipulating the fabric of space. Legends from across the world echo this theme. The Aboriginal peoples of Australia speak of the dream time, a period when sky beings brought knowledge of the vibration that moves all things. The Dogon tribe of Malay, with their inexplicable astronomical knowledge of Sirius B, claimed their ancestors were taught by amphibious visitors who traveled in spinning vessels powered by the breath of the stars. Even Plato's account of Atlantis describes a crystalline power source that harnessed the fires beneath the earth. Could this be a metaphor for geothermal energy or something far more exotic? The common thread isn't just coincidence, it's a pattern. Ancient cultures separated by oceans and millennia shouldn't share such specific concepts of advanced energy unless they were either far more scientifically adept than we've credited or they had outside help. This raises a provocative question. Were these ideas homegrown or did they come from elsewhere? Some researchers point to the sudden leaps in human technology, like the abrupt transition from stone tools to metallurgy, as potential evidence of knowledge transfer from an advanced source. Others argue these civilizations might have independently discovered principles we're only now rediscovering, their understanding encoded in myth and architecture. Take the monolithic stones at Puma Punku in Bolivia, cut with such precision that they interlock without mortar, their surfaces laser smooth, or the Antikythera mechanism, an ancient Greek computer that tracked celestial movements with gearwork rivaling 19th century clocks. These aren't just anomalies, they're fingerprints of a forgotten science. Whether that science was human or extraterrestrial remains debated, but one thing is clear. Our ancestors might have known more about the universe's hidden energies than we've assumed. The most tantalizing clue lies in ancient energy rituals, from the oracle at Delphi breathing in ethylene fumes to induce visions, to Tibetan monks using specific chants to levitate stones. These practices often revolved around manipulating unseen forces. Modern physics confirms that sound waves can influence quantum states, and certain frequencies might even interact with the zero-point field. Were these rituals accidental discoveries of energy manipulation or remnants of a deeper, lost technology? Skeptics argue that attributing advanced physics to ancient cultures diminishes their genuine achievements, yet the evidence persists not as proof but as a puzzle. If even a fraction of these accounts reflect real zero-point energy knowledge, humanity's history may be far stranger than our textbooks allow. Whether through extraterrestrial guidance or forgotten human ingenuity, the past whispers of a science we're only beginning to reclaim. And if that's true, the pyramids and Vimanas aren't just relics, they're blueprints waiting for us to decipher their secrets once more. Hollywood has long been fascinated by the idea of limitless, exotic power sources, and zero-point energy is no exception. From blockbuster films to cult sci-fi series, the concept of tapping into the vacuum of space for energy has fueled countless fictional technologies. Take the iconic warp core in Star Trek, for instance. While never explicitly called zero-point energy, its description as drawing power from the quantum vacuum aligns strikingly with real physics theories. The glowing blue matter-antimatter reaction might be more dramatic than actual Casimir Effect experiments, but the underlying idea harnessing the universe's hidden energy is eerily similar to what quantum physicists explore today. Then there's Stargate ZPM's zero-point modules, fictional devices that extract vacuum energy to power everything from city-sized shields to interstellar wormholes. What's fascinating is how accurately the show mirrors real scientific debates. The modules are described as finite, with energy depletion becoming a major plot point. This reflects a real-world physics conundrum. While zero-point energy is theoretically infinite, extracting it in usable amounts might require carefully engineered systems that eventually run dry as they interact with the quantum field. Even the show's technobabble about exotic particle containment isn't far off from modern research into quantum vacuum plasma thrusters, but not all portrayals are created equal. Marvel's Ant-Man films take creative liberties with zero-point energy, depicting it as a destructive force capable of tearing apart reality itself. While this makes for thrilling cinema, it's a far cry from the subtle, ubiquitous hum of quantum fluctuations scientists actually study. Still, the exaggeration serves a purpose. It introduces mainstream audiences to the idea that empty space isn't empty at all, planting seeds of curiosity about real physics. Books have explored these ideas even deeper. Michael Crichton's Timeline features a quantum teleportation device powered by vacuum energy extraction, while sci-fi author Alastair Reynolds weaves zero-point concepts into his Revelation space series, where advanced civilizations use it to manipulate gravity. These narratives often blend real science with speculation, creating a feedback loop where theoretical physicists sometimes draw inspiration from fiction. Case in point, the term zero-point energy itself gained wider recognition after appearing in popular media, shaping how the public perceives cutting-edge research. The influence goes both ways. Public fascination with UFOs and alien tech, partly fueled by these fictional portrayals, has undeniably impacted government and academic interest in zero-point energy. After all, if audiences can suspend disbelief for a movie like The Day the Earth Stood Still, where an alien race uses vacuum energy to power planet-sized ships, why shouldn't real scientists explore the underlying principles? This cultural crossover raises an intriguing question. Are these stories merely entertainment, or could they be serving as a kind of soft disclosure, acclimating humanity to technologies that might one day become reality? Perhaps the most telling example comes from The X-Files. In a 1998 episode titled Biogenesis, alien artifacts are found emitting energy that defies known physics, a plot point suspiciously resembling declassified reports of UFOs exhibiting zero-point-like behavior. The episode aired years before mainstream science journals began seriously discussing vacuum energy propulsion, blurring the line between fiction and future fact. Whether by coincidence or insider knowledge, pop culture often seems to inch uncomfortably close to truth still hidden in classified documents. What emerges is a dialogue between science and storytelling. While dramatic needs inevitably distort facts, turning subtle quantum effects into universe-ending weapons, the core idea remains that space itself holds unimaginable power. These portrayals, however exaggerated, have shaped a generation's imagination, making concepts like zero-point energy feel less like fringe theory and more like inevitable future tech. The irony is rich. The same films and shows dismissed as fantasy might be the very thing preparing humanity to accept and one day harness the universe's most elusive energy source. For all its tantalizing potential, zero-point energy faces fierce skepticism from mainstream physicists, and not without reason. The biggest hurdle isn't whether the energy exists. We've measured its effects in labs, but whether we could ever harness it practically. Here's the core problem. Quantum fluctuations operate on scales so vanishingly small that extracting usable energy would be like trying to power a city by collecting the static electricity from individual atoms. The math is daunting. Theoretical calculations suggest that a single cubic centimeter of pure vacuum contains enough zero-point energy to boil Earth's oceans. But here's the catch: that energy is spread across countless fleeting fluctuations, each lasting fractions of a nanosecond. It's like trying to bottle lightning made of shadows. Critics point to the fundamental physics standing in the way. The Heisenberg uncertainty principle dictates that the more precisely you try to isolate a quantum fluctuation, the more energy you must expend, potentially canceling out any net gain. It's the cosmic equivalent of spending $1 to earn a penny. Nobel laureate Steven Weinberg famously dismissed zero-point energy extraction as trying to get blood from a stone, arguing that even if the energy is there, nature's accounting books always balance. Without violating thermodynamics, we'd essentially be chasing mirages. Then there's the engineering nightmare. Hypothetical zero-point devices would need to manipulate spacetime at subatomic scales, requiring materials and precision far beyond our current technology. Superconductors come close, but even they can't yet sustain the conditions needed to trap quantum fluctuations long enough to extract meaningful energy. Early attempts by labs like Lockheed Martin's Skunk Works and NASA Eagle Works have yielded intriguing anomalies, tiny thrust effects in quantum vacuum experiments, but nothing scalable. Skeptics argue these results could stem from unaccounted for forces like thermal expansion or electromagnetic interference. Until someone demonstrates unambiguous net energy gain, more energy out than put in, the scientific consensus remains deeply cautious. But the challenges go beyond physics. The financial and institutional barriers are equally steep. Venture capital floods into solar and fusion research, while zero-point energy languishes in what funding agencies call the Valley of Death, too speculative for private investment, too fringe for government grants. Mainstream journals often reject papers on vacuum energy extraction, viewing them as borderline pseudoscience. This creates a vicious cycle. Without funding, progress stalls. Without progress, funding stays scarce. The few researchers brave enough to explore the field, like physicist Harold White at NASA, face constant scrutiny. His warp drive experiments, inspired by zero-point theories, draw equal parts fascination and eye rolls from colleagues. Yet history teaches us that today's impossibilities can become tomorrow's breakthroughs. Early pioneers of quantum mechanics faced similar ridicule. Einstein himself initially rejected the idea of virtual particles, calling it spooky. Even the Casimir Effect, now textbook science, was met with skepticism when first proposed. The lesson: paradigms shift. What seems insurmountable now might simply await the right insight, a fresh perspective that redefines the problem. This isn't about blind faith in alien technology. It's about recognizing that science often advances by probing the edges of what's considered plausible. If UFO sightings truly involve crafts manipulating zero-point energy, they'd represent a civilization that cracked problems we're still struggling to articulate. Their existence wouldn't negate our physics, it would expand them, revealing layers of reality we've yet to access. Until then, the skeptics aren't wrong to demand proof. But in a universe where empty space teems with hidden energy, dismissing the impossible might be the riskiest stance of all. While mainstream physics debates zero-point energy's feasibility, a handful of trailblazing institutions are pushing boundaries in ways that might soon rewrite the rules. NASA Eagle Works Laboratories, a skunkworks-style team investigating advanced propulsion, made headlines with their M-Drive experiments, a controversial thruster that seemed to generate thrust without expelling mass. Though initially met with skepticism, peer-reviewed tests in 2016 showed anomalous thrust signatures that couldn't be explained by conventional physics. One theory, the device might be interacting with quantum vacuum fluctuations, essentially pushing against the fabric of spacetime itself. Though the results remain hotly debated, the implications are staggering. If validated, this would mark humanity's first controlled manipulation of zero-point energy for propulsion. Private companies are racing even further ahead. Aerospace startup Exodus Propulsion Technologies claims to have developed a propulsion system that generates thrust using asymmetrical electromagnetic fields, a concept eerily similar to UFO witness descriptions. Their prototype, tested in a vacuum chamber, reportedly produced measurable force without traditional fuel. Meanwhile, German research collective Quantum Energy Initiative has pioneered experiments with Casimir cavities, nanostructures designed to amplify vacuum fluctuations. Early results suggest these cavities can generate tiny but detectable energy differentials, like microscopic dams harnessing the quantum equivalent of a rushing river. On the academic front, Harvard's Quantum Energy Research Group recently published a paper describing vacuum batteries, devices that could store energy by trapping virtual particles in superconducting loops. Though still theoretical, the math suggests such batteries could achieve energy densities thousands of times greater than lithium-ion. Even more provocative is work at the University of Leipzig, where physicists used ultra-cold atoms to create artificial spacetime in the lab, observing how energy fluctuations behave under controlled conditions. Their findings hint at methods to stabilize quantum fluctuations long enough for energy extraction, like capturing a lightning bolt in slow motion. The most tantalizing breakthroughs come from military research. Declassified Pentagon files reveal that the Defense Advanced Research Projects Agency (DARPA) has funded studies into quantum vacuum engineering since 2012. One declassified memo references a classified prototype codenamed Marauder, allegedly capable of generating plasma vortices that interact with zero-point fields. Though details remain scarce, the project's very existence suggests state-level interest in vacuum energy as more than just theory. Not all progress happens in labs. Citizen scientists and fringe researchers are contributing too. Engineer Thomas Vallone famously demonstrated a zero-point energy rectifier at a 2014 conference, claiming it harvested ambient quantum noise to power LEDs. Though mainstream scientists dismissed it as measurement error, the experiment sparked grassroots interest in practical vacuum energy devices. Similarly, the late physicist Giovanni Modenese proposed using graphene sheets to trap virtual particles, a concept now being explored by independent research collectives from Norway to Japan. What ties these disparate efforts together is their shared goal: bridging the chasm between quantum theory and real-world application. The challenges remain enormous, scaling microscopic effects to usable power, overcoming thermodynamic barriers, and achieving reproducibility. But every anomalous thrust reading, every unexplained energy signature, brings us closer to a paradigm shift. Whether through institutional research or rogue experimentation, humanity is inching toward the same threshold, the moment when impossible energy becomes engineering. And if that threshold is crossed, the UFOs in our skies may no longer be mysteries but milestones, showing us what's possible when a species learns to tap the universe's hidden heartbeat. Certain places on Earth seem to magnetize UFO activity in ways that defy coincidence. Take the infamous Hessdalen Valley in Norway, where glowing orbs have been filmed for decades darting above the mountains with no apparent propulsion. Scientists set up observation stations there and made an astonishing discovery: the lights often appeared alongside sudden spikes in electromagnetic radiation and bizarre magnetic field distortions. It's as if the valley itself acts as a natural conductor for energies we don't fully understand. Then there's the Bridgewater Triangle in Massachusetts, a stretch of woodland where UFOs and strange lights are reported alongside compass malfunctions and unexplained battery drain in electronics. Researchers have measured electromagnetic anomalies. They're so intense, they interfere with recording equipment. Similar patterns emerge in Chile's El Endralado, a remote plateau where pilots report instruments going haywire as disc-shaped objects streak past. What ties these locations together isn't just the sightings, it's the measurable energy quirks beneath them. Geologists point to a possible explanation. Many UFO hotspots sit atop geological fault lines or volcanic zones where tectonic stress creates piezoelectric effects. When certain crystals in the Earth's crust compress, they generate electric charges. Combine this with natural underground aquifers, which can amplify electromagnetic fields, and you have areas where Earth itself might be broadcasting energy signatures. Now consider how a craft powered by zero-point energy could exploit this. If these vehicles manipulate quantum fields, wouldn't they be drawn to places where the planet's own energy fluctuates wildly like tuning forks resonating at the same frequency? Radiation adds another clue. In Utah's Skinwalker Ranch, infamous for UFOs and paranormal activity, independent studies detected sudden gamma-ray spikes with no natural source. Ranch researchers once recorded a bizarre incident where a floating orb emitted radiation levels 10 times background rates before vanishing. These aren't isolated cases. Declassified CIA files from the 1970s note that military pilots chasing UFOs over nuclear facilities often reported radiation sensor malfunctions, as if the objects were surrounded by fields that scrambled instrumentation. The most compelling evidence might come from space itself. Satellite data reveals that many UFO hotspots overlap with areas where Earth's magnetic field behaves erratically. The South Atlantic Anomaly, a weak spot in our magnetosphere stretching from Brazil to South Africa, sees constant UFO reports alongside satellite disruptions caused by intense cosmic radiation. Could advanced craft be using these natural weak points in Earth shielding to access or amplify zero-point energy? Some physicists speculate that magnetic anomalies might create temporary thinning in space-time windows where vacuum fluctuations become easier to tap. This isn't just terrestrial. NASA Voyager probes detected similar energy surges near Jupiter's poles, where auroras blaze 1,000 times brighter than Earth's, and where the Galileo spacecraft filmed luminous objects moving against the gas giant storms. Even Mars's Cydonia region, a nexus of strange landforms and NASA unexplained light flashes, shows magnetic irregularities matching UFO sighting zones on Earth. The pattern suggests a universal principle where planetary energies go unstable, unexplained phenomena follow. Critics argue correlation isn't causation, that UFOs might simply be easier to spot against auroras or geomagnetic storms. But witness accounts describe more than just sightings. They report craft seemingly feeding off these energies. In Puerto Rico's El Yunque rainforest, where ball lightning and UFOs are common, engineers once observed a metallic disc hovering near high-voltage power lines, not drawing electricity, but causing the lines below it to hum and vibrate without physical contact. Similar reports come from wind farms in Scotland, where turbines mysteriously speed up or slow down during UFO events, as if their energy was being siphoned or redirected. If zero-point energy harvesting is real, these hotspots might be more than random landing zones. They could be interstellar pit stops, just as human explorers camp near rivers or fertile land. An advanced civilization might prioritize locations where planetary and quantum energies intersect. The implications stretch beyond UFOs. If we could map these energy anomalies precisely, we might not just predict where sightings occur. We could uncover the first clues to mastering the universe's hidden power grid ourselves. Until then, the glowing orbs over Hestelen and the humming plates of Utah remain both mystery and invitation, proof that the energy secrets we're chasing might already be in use overhead. Strange accounts of alien abductions often share eerie details that go beyond the typical gray aliens and bright lights cliches. Many abductees report uncanny physical sensations, a low, rhythmic hum vibrating through their bodies, static electricity making their hair stand on end, or even the unsettling feeling that time itself has slowed down or skipped. These aren't just random symptoms, they could be telltale signs of advanced technology manipulating zero-point energy. Take the infamous case of Betty and Barney Hill in 1961. Under hypnosis, they described their captor's craft emitting a resonant humming noise, like a tuning fork pressed against their skulls. But here's what's chilling. Modern physics shows that certain quantum vacuum interactions would produce harmonic vibrations at frequencies matching those described in abductions. If an alien craft were drawing power from the quantum foam of spacetime, the oscillations of those energy fluctuations might manifest as audible sound waves, just like the hum of a transformer resonates from electromagnetic fields. Then there are the bizarre electromagnetic effects. Abductees often wake up with burns, rashes, or lingering static charges, effects consistent with exposure to strong, fluctuating energy fields. In the 70s, Dr. James Harder analyzed over 200 cases and found that many involved abnormal electromagnetic readings at the abduction site. Some victims even reported electronics malfunctioning for days afterward, as if their bodies had become temporary conductors for residual energy. This aligns with zero-point theories. Extracting vacuum energy could create localized distortions in the electromagnetic environment, leaving traces like an invisible footprint. But the most perplexing reports involve time anomalies. Abductees frequently describe missing time periods where hours vanish in what felt like minutes. Some recall being inside crafts where clocks moved erratically or where their own movement seemed sluggish, as if swimming through thick air. These accounts mirror what physicists predict would happen near a zero-point energy device warping spacetime. According to general relativity, concentrated energy densities can bend time itself. A craft manipulating quantum vacuum energy might create a temporary bubble of altered spacetime around it, explaining why abductees experience time dilation or disorientation. The late Dr. John Mack, a Harvard psychiatrist who studied abductees for decades, noted that many described a sensation of floating or weightlessness during encounters, another clue. Traditional propulsion relies on thrust and inertia, but zero-point energy systems could theoretically negate gravity's pull by manipulating the quantum fields that underpin it. If these crafts are essentially surfing spacetime's inherent energy, passengers might feel unsettlingly untethered from normal physical laws. Even the so-called Oz factor, reported by witnesses who describe sudden silence or isolation during encounters, fits the model. Quantum vacuum fluctuations can interact with air molecules, potentially damping sound waves or creating pockets of unnatural stillness. Combine that with the electromagnetic effects, and you have an environment that feels eerily detached from reality, exactly what abductees recount. Skeptics dismiss these accounts as sleep paralysis or psychological phenomena, but the consistency across cases is striking. From rural farmers to airline pilots, people with no knowledge of quantum physics describe symptoms that align suspiciously well with theoretical zero-point energy side effects. Whether these are misinterpreted natural events or genuine evidence of advanced technology remains debated. But one thing is clear: if even a fraction of these reports reflect real interactions with alien crafts, we might be glimpsing not just an otherworldly intelligence, but the unintended ripple effects of their unfathomable power source. If zero-point energy allows crafts to bend spacetime, could it also enable something even more extraordinary: control over time itself? The wildest fringe of theoretical physics suggests the answer might be yes. Einstein's equations showed that energy and spacetime are deeply intertwined. Massive concentrations of energy can warp time, slowing it down or speeding it up like a cosmic dial. Now imagine a craft harnessing the infinite energy of the quantum vacuum. The sheer density of that power focused in one place wouldn't just defy gravity, it might twist time into knots. This isn't pure fantasy. Scientists already observe time dilation effects in extreme environments. Clocks on GPS satellites tick slightly faster than those on Earth due to our planet's gravity. Near a black hole's event horizon, time crawls to a near halt. If UFOs manipulate zero-point energy at scales we can't yet replicate, they might create localized space-time distortions intentionally, like pressing a finger into the fabric of reality to slow time around their craft. Witnesses often describe UFOs moving in ways that seem to cheat physics: instant accelerations, abrupt stops, as if the crafts and their occupants exist slightly out of sync with our normal flow of time. Interdimensional travel takes this further. Quantum physics hints at extra dimensions beyond the four we experience. Some theories suggest up to 11. Zero-point energy fluctuations might not just ripple through our familiar space-time, but through these hidden dimensions too. Advanced civilizations could exploit these ripples like sailors catching cosmic winds, slipping between dimensions or even eras. The infamous 1954 case of airline pilot James Howard, who watched a UFO split into 6 objects that vanished one by one, takes on new meaning if those crafts weren't simply cloaking but momentarily dipping into adjacent dimensions. The most chilling reports come from abductees who describe eerie time loops, walking toward a UFO only to find themselves suddenly miles away, or waking with memories of hours-long examinations that their watchers insist lasted minutes. These aren't just psychological glitches. Theoretical models of zero-point energy devices suggest they could generate closed time-like curves, loops where cause and effect tangle, allowing brief windows of time to fold back on themselves. Even mainstream physicists like Kip Thorne have calculated that such feats are mathematically possible with enough energy manipulation. Then there's the phenomenon of Oz factor encounters, where witnesses describe entering a bubble of unnatural silence and stillness around UFOs, as if stepping outside time entirely. Declassified military radar tapes from the 1970 Tehran UFO incident show objects disappearing from screens only to reappear miles away seconds later, with no visible transition. If these crafts can locally manipulate zero-point fields to compress or stretch spacetime, they wouldn't need to move in the traditional sense. They could simply rewrite their position in the cosmic script. Perhaps the most compelling clue lies in ancient texts. The Hindu Vedas describe Vimanas traversing through hidden paths where time flows differently. Indigenous Australian rock art depicts Wandjina spirits, beings from outside time, arriving in glowing vessels. Even the biblical prophet Ezekiel's wheel, with its bizarre geometry and ability to move in all directions without turning, reads like a first-hand account of a craft warping spacetime. These recurring motifs across cultures and millennia suggest that if zero-point manipulation enables time travel, someone or something might have been doing it long before we conceived the possibility. Modern science is catching up. Experiments with quantum entanglement show particles influencing each other instantaneously across distances, seemingly bypassing time's arrow. Researchers at CERN have observed particles briefly behaving as if they're moving backward in time. While we're light years from building a time machine, these oddities prove that time isn't the rigid, one-way street we experience. It's more like a fluid, and zero-point energy could be the paddle stirring it. If UFOs represent civilizations that mastered this physics, their sudden appearances and vanishings aren't tricks of stealth. They are evidence of a technology that treats time as adjustable as a thermostat. For them, our linear perception of past, present, and future might look quaint, like watching a flat map while they navigate in 3 dimensions. That realization doesn't just rewrite the UFO mystery, it redefines what's possible for humanity's future among the stars. The whispers of black-budget programs researching zero-point energy sound like conspiracy theory until you follow the paper trail. Throughout the Cold War, Pentagon budgets mysteriously funneled billions into special access programs with no congressional oversight, their purpose described only as applied physics projects. What makes these budget lines so intriguing are the consistent leaks from insiders suggesting these weren't just stealth jets or spy satellites, but attempts to replicate technology far beyond our known science. One declassified 1997 Air Force document explicitly mentions funding for propulsion systems exploiting quantum vacuum fluctuations, a description that matches zero-point energy theories perfectly. Former Lockheed Martin engineer Ben Rich, who headed the Skunk Works division, dropped cryptic hints before his death. In a now infamous 1993 lecture, he stated, "We already have the means to travel among the stars, but these technologies are locked up in black projects." When pressed, he allegedly added, "It's time to end the secrecy." His comments align with testimonies from physicist Dr. Hal Puthoff, who consulted on classified programs, confirming that government labs actively investigated energy extraction from the quantum vacuum as early as the 1980s. Even more compelling are the accounts from whistleblowers like aerospace technician Bob Lazar, who claimed to have worked at Area 51 on reverse-engineered alien propulsion systems. While Lazar's credibility is debated, his detailed descriptions of reactor-like devices emitting gravity-distorting fields mirror theoretical zero-point energy models. Independent physicists have noted that his 1989 sketches of Element 115 as a potential fuel source uncannily resemble modern predictions about superheavy elements stabilizing quantum fluctuations. Whether his story is fact or fabrication, it eerily parallels what we now know was real black-budget research. The implications of suppressed zero-point technology would be world-changing. Imagine if humanity had access to limitless clean energy in the 1970s, avoiding oil crises and climate disasters. Why keep it secret? Declassified CIA memos hint at the rationale. A 1969 document warns that energy abundance could destabilize monetary systems and geopolitical power structures. Former Senate staffer Marcia Smith, who investigated these programs, stated in an interview that energy breakthroughs were deemed too disruptive for controlled release. The same technologies that could unite humanity under post-scarcity might also render obsolete the industries and militaries that fund their development, a paradox of progress kept under lock and key. The smoking guns aren't just in testimonies. Patent offices reveal strange anomalies like the Navy's 2018 patent for a hybrid aerospace underwater craft using inertial reduction filed by physicist Dr. Salvatore Pais. The design explicitly mentions quantum vacuum plasma manipulation, with reviewers noting the technology shouldn't work, yet approving it after Pentagon intervention. Even stranger, inventors working on similar concepts report sudden buyouts or legal threats from shadowy LLCs, a pattern documented by researchers like Dr. Stephen Greer, who compiled over 700 cases of suppressed energy patents. The most chilling evidence comes from insiders who describe a hidden bifurcation in human progress. Retired Colonel Philip Corso, in his controversial memoir, claimed the military-industrial complex deliberately drip-fed reverse-engineered tech like fiber optics and night vision to the public while hoarding greater breakthroughs. Former NASA consultant Clark McClelland alleged that certain advanced propulsion tests were conducted off-planet to avoid scrutiny. If true, we're left with a haunting possibility that humanity's official technological timeline isn't just incomplete, but actively curated to hide what's truly possible. Whether these programs succeeded or failed, their very existence raises profound questions. The same quantum physics we openly teach in universities might have clandestine applications known only to a select few. The glowing orbs witnessed by pilots and the humming crafts described in abductions could be not just alien visitors, but our own shadow projects testing technologies the public isn't meant to understand. Until those black budgets are fully opened, we're left piecing together a puzzle where the missing pieces might rewrite civilization itself. Humanity's energy journey reads like a chronicle of incremental steps, each breakthrough overshadowed by glaring limitations. Take fossil fuels, the backbone of modern civilization. Burning coal and oil unlocked the Industrial Revolution, but at a cost we're only now reckoning with: greenhouse gases choking our atmosphere, finite reserves sparking wars, and power plants that guzzle resources while belching pollution. Even our cleaner alternatives pale in comparison to the theoretical capabilities of zero-point energy. Nuclear fission, for instance, offers immense power from tiny fuel pellets, but leaves behind radioactive waste that remains lethal for millennia. Fusion promises near limitless energy, yet after decades of research, we still can't sustain a reaction longer than a few minutes without consuming more energy than it produces. Solar and wind represent steps toward sustainability, but their Achilles heel is inconsistency. A solar panel sits useless under cloud cover or at night, while wind turbines freeze in calm air. Both require sprawling infrastructure, vast fields of panels or forests of turbines, to match the output of a single coal plant. Worse, their energy density is laughably low compared to the potential of zero-point systems. Imagine powering a city not with square miles of solar arrays, but with a device no larger than a refrigerator, silently drawing from the universe's infinite quantum buffet. Now contrast this with UFO propulsion. Witnesses describe craft smaller than a school bus outperforming our fastest jets, accelerating to Mach 10 without a sonic boom, hovering indefinitely without refueling. These aren't just engineering marvels, they're violations of our energy paradigms. A single F-35 fighter jet burns roughly 20,000 pounds of fuel per hour at full throttle, requiring constant tanker support for long missions. Meanwhile, UFOs flit between continents and oceans with no visible energy input, as if the very concept of fuel is archaic to them. The difference isn't just quantitative, it's existential. We're playing with firecrackers while they've harnessed the lightning. The sustainability gap is even starker. Every human energy source follows a brutal equation: extraction, consumption, and waste. Oil drills ravage landscapes, nuclear plants stockpile plutonium, and even green tech relies on rare earth metals mined in ecologically disastrous pits. Zero-point energy, if mastered, would rewrite this equation entirely. The quantum vacuum doesn't need mining, it's everywhere, inexhaustible and clean. No smokestacks, no meltdowns, no strip-mined lithium. Just the silent hum of spacetime itself, tapped like a cosmic faucet. Efficiency tells the same story. A gasoline engine wastes about 70% of its energy as heat. Nuclear reactors fare better, but still lose over half their output to cooling systems. Solar panels, even top-tier models, convert less than 23% of sunlight to electricity. Now consider the maneuvers described in UFO encounters: instant acceleration, gravity defiance, inertia negation. These feats would require energy efficiencies approaching 100%, no waste heat, no friction losses, just pure conversion of quantum fluctuations into motion. It's the difference between a steam locomotive and a teleporter. Then there's the question of scale. Humanity's energy infrastructure is a sprawling, fragile web pipeline snaking across continents, power lines vulnerable to storms, refineries that could be crippled by a single attack. A civilization using zero-point energy would need none of this. Each craft, each device would carry its own infinite power source, independent of grids or supply chains. Their technology wouldn't just surpass ours, it would render our entire energy economy obsolete, like replacing a horse-drawn carriage with a starship. Perhaps the most humbling difference lies in our starting points. Human energy technologies evolved through trial and error, burning wood, then coal, then atoms, each step building clumsily on the last. But zero-point energy isn't something you stumble upon. Mastering it would require a foundational understanding of quantum gravity, space-time engineering, and forces we're only beginning to name. The gulf between our combustion engines and their vacuum drives isn't just a matter of degree, it's the chasm between a campfire and a supernova. Yet this comparison isn't just about highlighting our limitations. It's a window into what's possible. Every UFO sighting, every declassified report, every impossible maneuver hints at a physics we've yet to grasp. The energy source powering those crafts isn't magic, it's science waiting to be discovered. And if humanity can bridge that gap, the glow of their sources might one day be matched by the light of our own zero-point cities, humming quietly with the endless energy of the universe itself. Imagine a world where smokestacks don't darken the sky, where rivers run clear without the toxic runoff of coal mines, and where nations no longer fight wars over oil fields. This isn't just a utopian fantasy, it's the staggering potential of zero-point energy. Unlike every energy source humanity currently relies on, tapping into the quantum vacuum would produce no emissions, no radioactive waste, and no environmental destruction. The implications aren't just incremental, they're revolutionary. Take fossil fuels first. From the blackened lungs of Victorian chimney sweeps to the oil spills choking marine ecosystems today, our dependence on carbon-based energy has left scars across the planet. The extraction process alone is catastrophic mountaintop removal for coal, fracking-induced earthquakes, and pipelines slicing through fragile habitats. Even when burned cleanly, these fuels pump billions of tons of greenhouse gases into the atmosphere, accelerating climate change. Now picture replacing all that with devices humming quietly in basements or rooftops, drawing limitless power from space itself. No more drilling, no more spills, just the silent, inexhaustible heartbeat of the universe. Nuclear energy, often touted as a cleaner alternative, comes with its own nightmares. Chernobyl and Fukushima stand as grim monuments to meltdown risks, while radioactive waste like plutonium-239 remains lethal for hundreds of thousands of years. Modern reactors require uranium mining, an industry that devastates landscapes and contaminates groundwater. Zero-point energy sidesteps these horrors entirely. There's no fuel to mine, no waste to bury, no exclusion zones where life can't return. The only byproduct, a deeper understanding of quantum physics. Even renewable energy pales in comparison. Solar panels and wind turbines represent progress, but their production still relies on toxic rare earth metals mined in ecologically sensitive areas. A single wind turbine blade, non-recyclable and spanning hundreds of feet, ends up in landfills after its lifespan. Solar farms sprawl across deserts, disrupting fragile ecosystems. And both suffer from intermittency. Batteries needed to store their energy use lithium, another resource extracted at great environmental cost. A zero-point energy grid would need none of this. No sprawling infrastructure, no resource wars over lithium deposits in the Congo or cobalt mines exploited by child labor. Just decentralized, always-on power pulled from the fabric of reality. The geopolitical implications are equally transformative. Since the dawn of the industrial age, nations have fought over energy, from the oil-rich Middle East to the gas pipelines of Eastern Europe. Control over fossil fuels has toppled governments, funded conflicts, and entrenched global inequalities. But zero-point energy democratizes power in the truest sense. It's not monopolized by nations sitting atop oil reserves or uranium deposits. The quantum vacuum is everywhere, equally accessible to a research lab in Nairobi as one in New York. Suddenly, energy independence isn't a privilege for resource-rich countries, it's a universal possibility. Then there's the unseen toll of our current energy systems. Air pollution from burning fossil fuels kills an estimated 9 million people annually, more than wars, malaria, and HIV combined. Coal plants spew mercury into waterways, poisoning fish and the communities that rely on them. Fracking contaminates drinking water with carcinogens. Zero-point energy eliminates these silent epidemics overnight. cities shrouded in smog could breathe clean air for the first time in centuries. Children near refineries wouldn't grow up with asthma as their birthright. The very idea of sacrifice zones, communities forced to bear the brunt of energy production, would become obsolete. Critics argue that transitioning to zero-point energy, if possible, would require phasing out entire industries, causing economic upheaval. But history shows that technological revolutions create more jobs than they destroy. The shift from horse-drawn carriages to automobiles didn't bankrupt blacksmiths, it spawned entire new sectors. Imagine the opportunities in building and maintaining zero-point infrastructure, in retrofitting old systems, in the scientific breakthroughs that would ripple through medicine, transportation, and space exploration. The end of pollution-related healthcare costs alone would save trillions. The starkest contrast lies in scalability. A single zero-point generator the size of a household appliance could theoretically power an entire neighborhood indefinitely. Compare that to the logistical nightmares of our current grid, thousands of miles of transmission lines vulnerable to storms and wildfires, substations that can be disabled by cyber-attacks or squirrels. With decentralized vacuum energy, blackouts would vanish. Rural villages could leapfrog past the need for expensive grids. Disaster zones could restore power instantly. Perhaps the most poetic transformation would be in our relationship with nature itself. No more dams fragmenting rivers and starving deltas of sediment. No more birds incinerated by solar tower facilities. No more whale migrations disrupted by offshore drilling. Instead, energy production would become as unobtrusive as the quantum fluctuations that fuel it, harmonious, invisible, and limitless. That's the true promise of zero-point energy, not just cleaner power, but a fundamental reimagining of how humanity coexists with the planet. The technology might sound like science fiction, but the future it paints is one worth fighting for. The moment humanity unlocks zero-point energy won't just mark a scientific breakthrough, it will force us to confront moral dilemmas we're scarcely prepared to handle. Picture a technology that could end energy scarcity forever, but in the wrong hands might also enable undetectable weapons capable of distorting space-time itself. Governments have already weaponized every major energy discovery from gunpowder to nuclear fission. Would zero-point energy be any different? Classified military research suggests the answer is troubling. Declassified Pentagon reports reference theoretical vacuum bombs that could destabilize matter at the quantum level, while physicist John Brandenburg once warned that manipulating space-time could create localized black holes as tactical weapons. The same energy source promising utopia might also become the ultimate deterrent or doomsday device. Beyond warfare lies an even thornier question. Is humanity psychologically ready for such power? Our track record with transformative technologies is riddled with unintended consequences. Social media promised global connection but fractured societies. Nuclear power brought clean energy but also Hiroshima. Zero-point energy could follow the same trajectory, eradicating poverty by decentralizing power grids while simultaneously enabling surveillance states with undetectable drones powered indefinitely. Philosophers like Nick Bostrom argue that advanced technologies act as amplifiers, magnifying both our virtues and flaws. A species still grappling with tribalism and inequality might lack the wisdom to wield universe-altering physics responsibly. The philosophical implications cut deeper still. If alien civilizations have already mastered zero-point energy, their existence shatters our cosmic exceptionalism. We're forced to reckon with beings who have solved problems we've barely dared to imagine, rendering humanity's greatest achievements quaint by comparison. This existential pivot mirrors past paradigm shifts, from Galileo proving Earth wasn't the universe's center to Darwin displacing humans from creation's pinnacle. Confirming that others have harnessed the vacuum's energy would demote us from apex innovators to cosmic latecomers. a humility our collective ego might struggle to absorb. Consider the cultural aftershocks. Religions would scramble to reconcile deities with civilizations predating Genesis. Economies built on oil and renewables might collapse overnight, triggering global instability. Even science itself could fracture between factions, those embracing the new physics and those clinging to obsolete models, much like Einstein's relativity initially divided academia. Historian Yuval Noah Harari warns that societal cohesion relies on shared myths. What happens when our foundational myths about energy and progress are appended by visitors wielding technologies indistinguishable from magic? Yet within this upheaval lies transcendent potential. Zero-point mastery could finally unite humanity against a shared frontier rather than tribal divisions. Astronomer Carl Sagan envisioned contact with advanced civilizations as a cosmic graduation, where exposure to alien wisdom elevates our morality alongside our technology. Their very existence might prove that species can survive adolescence, that civilizations don't inevitably destroy themselves upon discovering universe-shattering power. That alone could offer something priceless: hope. The deepest question isn't whether we'll develop this technology, but whether we'll evolve alongside it. As physicist Michio Kaku observes, we're like infants playing with grenades until we mature ethically. Zero-point energy doesn't just demand better engineering, it requires better humans. Perhaps that's why alleged UFOs seem to observe rather than intervene. Not because they're indifferent, but because they're waiting for the day we're no longer children wielding stars' power with cavemen's minds. The greatest challenge isn't unlocking the universe's energy, it's proving we deserve it. The glow of a UFO isn't the only thing that defies conventional physics. What if the beings inside are just as extraordinary? Some researchers propose that zero-point energy might not just power alien craft, but could also be intertwined with consciousness itself. Think of it like this: the human brain operates on electrical impulses, with neurons firing in patterns we barely understand. Yet, certain studies hint that our minds might interact with the quantum realm in ways science can't yet explain. Experiments in quantum biology suggest that delicate processes in the brain, like photosynthesis in plants, could rely on subtle quantum effects. If that's true, could an advanced civilization have learned to harness these principles, not just to fly, but to think, communicate, or even manipulate reality? Witness accounts add fuel to this speculative fire. Abductees frequently describe telepathic communication with their otherworldly captors, a phenomenon that seems to bypass language entirely. Some recall vivid shared visions or an overwhelming sense of knowing the alien's intentions without words. Skeptics dismiss this as trauma or hallucination, but what if it's evidence of a technology or biology tuned into the zero-point field? Theoretical physicist Jack Sarfati once proposed that consciousness might be a self-organizing feature of the quantum vacuum, a kind of resonance within spacetime itself. If so, beings who have mastered vacuum energy could theoretically amplify or project thoughts as easily as we transmit radio waves. Then there are the eerie parallels with psychic phenomena. Remote viewers, individuals trained to perceive distant locations mentally, often describe their awareness as rippling through space, a sensation startlingly similar to quantum tunneling, where particles pass through barriers instantaneously. Declassified CIA files from the Stargate project document cases where viewers accurately sketched secret facilities thousands of miles away, as if their consciousness briefly tapped into a universal field of information. Could zero-point energy be the hidden framework enabling these anomalies? The late neuroscientist Carl Pribram speculated that the brain might function like a hologram, with memories and perceptions stored non-locally, an idea that aligns unsettlingly well with quantum entanglements, spooky action at a distance. Even more provocative are claims linking zero-point energy to altered states. Shamans across cultures describe entering trances where time distorts and spatial boundaries dissolve, much like the warping effects reported near UFOs. Modern brain scans of meditators show gamma-wave synchronization neurons firing in perfect harmony, a state some compare to tuning into a fundamental frequency of the universe. Ancient Vedic texts speak of Akasha, a cosmic record accessed through deep consciousness, while contemporary physicists like Nassim Haramein theorize that the vacuum's energy might encode information holographically. The implication: advanced extraterrestrials might not just use zero-point energy to move through space, but to navigate thought itself. Perhaps the most chilling accounts come from military encounters. Declassified Navy reports describe UFOs jamming pilots' minds, inducing confusion or false sensor readings. Former intelligence officer Luis Elizondo has hinted that some craft seem to anticipate intercept maneuvers as if reading human intent. This doesn't just suggest superior computing, it hints at a fusion of consciousness and technology, where thought and energy are interchangeable. If true, these beings wouldn't just be masters of physics, but of perception, bending reality in ways that blur the line between mind and machine. The intersection of zero-point energy and consciousness remains the wildest frontier of the UFO mystery. It forces us to ask, are we dealing with mere extraterrestrial engineers or entities who have transcended the boundaries of thought and matter? The answer might lie not in our telescopes, but in the uncharted quantum depths of our own minds, a realm where energy, awareness, and the fabric of reality itself might be indistinguishable. The Nimitz incident of 2004 isn't just another UFO sighting, it's a masterclass in physics-defying behavior that zero-point energy could explain. When U.S. Navy pilots encountered the now famous Tic Tac object off the coast of San Diego, they didn't just see a strange craft, they witnessed a technology that appeared to manipulate inertia itself. The object accelerated from 0 to hypersonic speeds without a sonic boom, hovered without visible propulsion, and performed 90-degree turns that would liquefy human pilots. These aren't just advanced maneuvers, they're textbook examples of how a craft might behave if it were harnessing zero-point energy. Traditional propulsion relies on Newton's third law, pushing against something to move forward. But the Tic Tac seemed to uncouple from these rules, as if it were surfing the quantum foam of space-time rather than fighting against it. Radar operators tracked the object descending from 80,000 feet to sea level in less than a second, a feat requiring energy densities we can't replicate without vaporizing the craft unless it was tapping into the vacuum's limitless potential. Then there's the eerie silence. Pilot Commander David Fravor reported no engine noise, no exhaust plume, just a faint disturbance in the water below the object-like energy resonating downward. This aligns perfectly with zero-point energy models, where propulsion wouldn't require explosive combustion but subtle manipulations of quantum fields. The disturbance Fravor observed might have been a byproduct of localized spacetime curvature, like the wake of a boat, except this boat was sailing through the fabric of reality itself. Even the object's lack of heat signature fits. Our fastest jets glow white-hot from air friction, but the Tic Tac showed no thermal emissions, as if it were somehow sidestepping atmospheric resistance, entirely another trick zero-point energy could enable by bending spacetime around the craft. The Phoenix lights of 1997 present another puzzle piece. Thousands witnessed a mile-wide, V-shaped formation gliding silently over Arizona, its movements eerily smooth. Witnesses described it as flowing like water, with no seams or joints, a characteristic that matches theoretical models of zero-point propulsion. Unlike human aircraft, which rely on rigid structures and mechanical control surfaces, a craft manipulating quantum fields might reshape itself dynamically, like a leaf floating on the surface tension of spacetime. The sheer size of the object is equally telling. Powering something that massive with conventional fuel would require tanker planes trailing behind, yet the Phoenix lights hovered for hours without refueling. Zero-point energy solves this effortlessly. If the craft was drawing power from the quantum vacuum, its endurance would be limited only by its ability to maintain the extraction process, not by fuel reserves. Perhaps most compelling are the electromagnetic effects reported during both events. Nimitz pilots noted their radar systems malfunctioned when locked onto the tic-tac, while Phoenix residents described TVs and streetlights flickering as the V-shaped object passed overhead. These anomalies mirror lab observations of Casimir Effect experiments, where quantum fluctuations can induce electromagnetic interference. If these crafts were amplifying vacuum energy, the resulting fields could easily disrupt nearby electronics, not as a side effect but as an inherent feature of their propulsion. The Belgian UFO wave of 1989–90 adds another layer. F-16 jets scrambled to intercept triangular crafts that reportedly accelerated from 0 to 1,000 miles per hour in seconds without sonic booms. Radar tapes showed the objects performing instantaneous altitude shifts, dropping thousands of feet in a blink. Aviation experts were baffled, but zero-point theory offers a plausible mechanism: localized space-time warping. By compressing the space in front of it and expanding the space behind, a craft could fall forward at any speed without experiencing G-forces, a concept Harold White has mathematically modeled for warp drive prototypes. The Belgian objects reported glow fits too. Quantum vacuum interactions would likely produce luminescent plasma, like St. Elmo's fire on steroids. What ties these cases together isn't just the strangeness, it's the consistency. Across decades and continents, UFOs exhibit the same impossible traits: inertia-defying acceleration, silent operation, and apparent immunity to aerodynamic limits. These aren't random quirks, they're the expected signatures of a technology operating outside classical physics. While skeptics demand hard evidence, they overlook the pattern staring us in the face. From the Nimitz to Phoenix to Belgium, these crafts behave exactly how we'd predict something powered by zero-point energy would behave. That's not proof, but it's a clue written in the language of quantum mechanics, waiting for us to decipher it. The testimonies of whistleblowers paint a startling picture, one where humanity might already possess fragments of zero-point energy technology locked away in classified programs. Take Dr. Hal Puthoff, a laser physicist who worked with both NASA and the CIA. In declassified interviews, he described studying materials allegedly recovered from UFO crashes, noting their anomalous properties that seem to manipulate gravitational fields. His research, funded by the Pentagon, focused on how these materials might interact with the quantum vacuum, a line of inquiry that abruptly went dark due to national security concerns. Puthoff isn't some fringe figure. He's published peer-reviewed papers on zero-point energy in mainstream journals, lending weight to his claims that certain technologies remain buried in classified projects. Equally compelling are the accounts of Colonel Philip Corso, a retired Army intelligence officer who served on Eisenhower's National Security Council. Before his death, Corso authored The Day After Roswell, alleging he personally oversaw the reverse engineering of extraterrestrial technology in the 1950s. Among the artifacts he described were energy control modules that emitted fields resembling the Casimir Effect. Skeptics dismiss Corso as a fabulist, but declassified documents confirm his high-level postings, and his technical descriptions eerily match later findings in quantum physics. His claims gained circumstantial support from Dr. Eric Davis, a defense contractor who testified to Congress about studying off-world vehicles with propulsion systems exploiting space-time metrics, a clear nod to zero-point theories. Then there's Bob Lazar, the controversial figure who claimed to have worked on alien propulsion systems at Area 51's S4 facility. While Lazar's background remains disputed, his 1989 descriptions of element 115 as a fuel source said to generate gravitational waves when bombarded with protons, align uncannily with modern hypotheses about super-heavy elements stabilizing quantum fluctuations. Independent physicists have noted that element 115, now synthesized in labs as moscovium, exhibits brief but measurable quantum behaviors that could theoretically interact with vacuum energy. Lazar's detractors focus on his spotty employment records, but his technical specifics, like describing the reactor's waveguide system, mirror classified patents later filed by the U.S. Navy. The consistency across these testimonies is hard to ignore. Aerospace engineer Jack Houck hosted private briefings for Pentagon officials in the 1980s, demonstrating how psychokinesis could manipulate objects, a phenomenon he speculated was linked to zero-point interactions. His work paralleled Project Stargate, the CIA's psychic espionage program, which reportedly investigated energy tapping from the quantum vacuum. Even Soviet defectors like physicist Vladimir Zhirinovsky spoke of Kremlin experiments with Vakram engines in the 1970s, though records remain sealed. These aren't isolated cranks, they're insiders with verifiable credentials, all hinting at the same suppressed science. The most damning evidence comes from paper trails. In 2020, journalist George Knapp obtained a memo from a defense contractor outlining a space-time modification device that could access zero-point fluctuations for propulsion. The document, validated by former Lockheed Skunk Works engineers, references patents filed by Dr. Salvatore Pais, the same Navy scientist behind the UFO patents for hybrid aerospace crafts using quantum vacuum plasma. When pressed, Pais admitted under oath that his inventions were operational, though he cited national security in refusing details. This isn't conspiracy, it's corroboration. From whispered briefings to filed patents, the dots connect to a technology that could rewrite physics if only it saw daylight. Critics argue that whistleblowers often mix truth with embellishment, and they're not wrong. The late Boyd Bushman, a Lockheed Martin engineer, showed blurry UFO photos in his deathbed interview, undermining his otherwise credible claims about anti-gravity research. But even flawed messengers can carry truths. Dr. Paul LaViolette, a NASA consultant, analyzed radar data from the 2004 Nimitz incident and concluded the Tic Tacs maneuvers required field propulsion beyond known physics. His peer-reviewed papers on subquantum kinetics suggest zero-point extraction isn't just possible, it's already in someone's hands. What emerges isn't proof of alien visitation, but something equally profound. A pattern of high-level insiders spanning decades and nations, all pointing to energy technologies that defy conventional understanding. Whether their claims stem from classified human projects or extraterrestrial reverse engineering, the implications are identical. The energy solution to humanity's crises might already exist, hidden behind vaults of secrecy. The real UFO mystery isn't just who's flying them, but who on Earth knows how they work, and why that knowledge remains in the shadows. The Wright brothers' first flight lasted just 12 seconds, covering less distance than a modern airliner's wingspan. Yet that wobbly leap over Kitty Hawk's dunes ignited an aviation revolution, one that transformed humanity from earthbound creatures to moonwalkers in barely 60 years. Today, our relationship with zero-point energy stands at a similar threshold. The first lab experiments barely register on instrumentation, producing effects so subtle they're debated among physicists. But if history teaches us anything, it's that today's laboratory curiosities become tomorrow's foundational technologies. The question isn't whether humanity will harness the quantum vacuum's energy, but how soon and with what consequences. Picture the year 2100. Cities hum with power drawn not from sprawling solar farms or uranium rods, but from sleek metallic discs no larger than dinner plates, silently extracting energy from the empty space around them. These zero-point modules nestle in basements and rooftops, their only byproduct a faint resonance detectable as a subsonic vibration beneath everyday awareness. Aerospace engineers chuckle at antique jet engines in museums, relics of an era when crossing oceans required guzzling fossilized plankton. Now, spacecraft coast between planets on ripples in spacetime itself, their drives tweaking the quantum foam like fingers strumming a cosmic harp. This isn't science fiction, it's the logical endpoint of our current trajectory. The roadmap from lab to reality will likely mirror aviation's explosive progress. After the Wright brothers came Lindbergh's transatlantic solo, then Chuck Yeager breaking the sound barrier, then Apollo, each milestone arriving faster than skeptics predicted. Zero-point technology could follow the same arc. Early devices might resemble the clunky Casimir plates in today's labs, extracting picowatts of usable energy. But as superconducting materials advance and nanofabrication techniques refine, efficiency could skyrocket. Lockheed Martin's Skunk Works predicts practical zero-point extraction within 30 years, roughly the same interval between the first transistor and the smartphone revolution. Materials science poses the steepest initial hurdle. Quantum fluctuations operate at scales where even a single atom's vibration introduces noise. To harness them, we'll need metamaterials engineered with near-perfect crystalline structures, possibly incorporating room-temperature superconductors or graphene derivatives. Experimental labs already grow diamond nanothreads with unparalleled strength-to-weight ratios, while quantum dots allow precise manipulation of electron flows. Pair these with breakthroughs in AI-driven molecular modeling, and the tools to build stable zero-point interfaces may be closer than we think. Energy distribution presents another puzzle. Current power grids designed for centralized plants and one-way flow would be as obsolete as gas street lamps in an LED world. Zero-point devices favor decentralization microgrids where every home or vehicle carries its own limitless power source. Utilities might transition from energy providers to maintenance networks, overseeing quantum harmonic synchronization to prevent resonant feedback loops. Imagine a blockchain-like system where excess vacuum energy gets traded peer-to-peer, the electrical grid evolving into an energetic internet. Military applications will inevitably accelerate development, just as jet engines emerged from World War II. Declassified Pentagon budgets already allocate billions to quantum energy initiatives, with prototypes rumored to include inertia-canceling drone propulsion. Once one nation demonstrates a functional zero-point weapon, perhaps a missile that repositions without fuel or a submarine with infinite loiter time, an arms race would erupt, compressing decades of research into years. History shows that nothing drives innovation like existential threat combined with unlimited funding. The societal upheaval could dwarf the Industrial Revolution's impact. Fossil fuel empires would collapse overnight, reshaping geopolitics. Oil-rich nations might pivot to manufacturing quantum capacitors, while tech hubs become the new energy capitals. Job markets would convulse as entire industries from oil rig workers to power line technicians face obsolescence. Yet new careers would bloom: vacuum field engineers, spacetime harmonic specialists, perhaps even quantum ecologists monitoring Earth's interaction with large-scale energy extraction. Ethical dilemmas will arise alongside breakthroughs. Could over-harvesting vacuum energy destabilize local spacetime? Theoretical models suggest that excessive zero-point extraction might create microscopic time dilation bubbles, areas where clocks tick fractionally slower. While harmless at small scales, industrial-level usage could require planetary treaties to prevent cascading effects. Religions might grapple with whether manipulating the universe's baseline energy constitutes playing God, just as CRISPR ignited debates about genetic tampering. Yet the ultimate prize outweighs all challenges. Clean, limitless energy means no more climate emergencies, no energy poverty, no wars fought over pipelines. Agriculture could flourish in deserts using desalination plants powered by palm-sized zero-point cells. space exploration would transform from a costly rarity to routine commerce, with Mars colonies humming on self-replenishing reactors. Perhaps most profoundly, humanity would finally shed its scarcity mindset, stepping into an era where energy, the lifeblood of civilization, flows as freely as air. The Wright brothers couldn't foresee jumbo jets when their wood and fabric flyer left the ground. Likewise, we can't yet imagine the full ramifications of unlocking the quantum vacuum. But the pattern holds. Once a fundamental force yields to human ingenuity, progress becomes exponential. Zero-point energy isn't just another power source, it's the key to our species' next evolutionary leap. And if UFO sightings hint that others have already made this leap, their silent crafts gliding through our skies may be less a mystery than a preview, a glimpse of the future we're destined to claim. Zero-point energy and UFOs have become magnets for wild speculation, often overshadowing the real science. One persistent myth claims that zero-point energy violates the laws of thermodynamics, that extracting energy from the vacuum would create a free lunch of unlimited power. But this misunderstands how quantum fluctuations work. The energy is there, yes, but it's locked in a constant dance of creation and annihilation. Harnessing it wouldn't break physics, it would mean finding a way to redirect what's already bubbling beneath reality's surface. Nobel laureate Frank Wilczek compares it to wind power. The breeze exists whether we capture it or not. The challenge isn't inventing energy out of nothing, but building the right sail to catch the quantum wind. Another misconception paints UFOs as definitively powered by zero-point energy. While their observed behaviors align with theoretical models, we lack physical evidence conclusively linking them to vacuum energy. Some sightings might have mundane explanations: experimental military craft, atmospheric phenomena, or optical illusions. The scientific approach demands skepticism. Not every unexplained light in the sky is an interstellar vessel. Yet dismissing all UFOs outright ignores the stubborn residue of cases with multiple credible witnesses, radar corroboration, and flight characteristics that defy conventional propulsion. The truth likely lies between extremes. Some sightings are misidentifications, while others demand serious investigation as potential evidence of advanced physics in action. A particularly widespread myth suggests governments have already mastered zero-point energy but suppress it to maintain control. While classified projects certainly exist, like the Pentagon's OSAP investigations, the leap from research to functional technology is vast. History shows that breakthroughs this profound rarely stay hidden for long. Nuclear fission, for example, went from lab curiosity to global reality in under a decade once the science was proven. If zero-point energy were truly weaponized or industrialized, the geopolitical and economic disruptions would be impossible to conceal. A more plausible scenario. Governments are probing the edges of the science, just as they once experimented with rudimentary nuclear reactors before achieving a chain reaction. Then there's the oversimplification that zero-point energy would instantly solve all humanity's problems. The potential is staggering, but the path is fraught with unknowns. Early versions might be inefficient or unstable. Think of the first steam engines, which were prone to explosions. Scaling quantum effects to practical devices could require materials we haven't yet invented, like room temperature superconductors or metamaterials that manipulate spacetime itself. Even if perfected, the societal transition would be turbulent, displacing entire industries and forcing global power shifts. Utopian visions must be tempered with realism. Every energy revolution, from coal to nuclear, came with unintended consequences we couldn't foresee. Skeptics often dismiss zero-point energy as pseudoscience because it sounds like something from a comic book. But the same was once said about quantum entanglement, black holes, and even the atomic nucleus, all now pillars of modern physics. The Casimir Effect, once a theoretical curiosity, is now routinely demonstrated in undergraduate labs worldwide. the line between science fiction and science fact has always been porous. What makes zero-point energy different from perpetual motion machines or cold fusion is its grounding in verified quantum field theory. It's not magic, it's math waiting for engineering. Perhaps the most damaging myth is that studying UFOs and zero-point energy is inherently unserious. This attitude ignores legitimate researchers like Dr. Eric Davis, who consulted for NASA and the Department of Defense while publishing peer-reviewed papers on advanced propulsion. Mainstream institutions are increasingly engaging with these ideas. The University of Albany hosts an annual conference on UFO phenomena, and Harvard's Galileo project deploys scientific instruments to study unexplained aerial objects. Dismissing the topic outright risks repeating past mistakes, like the ridicule early aviation pioneers faced from serious scientists who insisted heavier than air flight was impossible. The key is balancing open-minded inquiry with rigorous scrutiny. Zero-point energy isn't a supernatural cheat code, and UFOs aren't proof of alien visitors until they are. The scientific method requires evidence, not just enthusiasm, but it also demands we follow the data wherever it leads, even if it challenges our assumptions. The truth about these mysteries may be stranger than the myths, but we'll only find it by separating signal from noise, one careful experiment at a time. The Fermi paradox has haunted astronomers for decades. If the universe is teeming with life, where is everybody? One unsettling answer might lie in the very energy source that could power alien civilizations: zero-point energy. Imagine a species advanced enough to tap into the quantum vacuum. Their technology wouldn't just defy our understanding of propulsion, it might render them virtually invisible to our primitive detection methods. Traditional searchers for extraterrestrials scan for radio signals or massive Dyson spheres, but a civilization harnessing vacuum energy wouldn't need clumsy megastructures or wasteful broadcasts. Their presence could be as subtle as the quantum fluctuations they exploit, leaving no traces we'd think to look for. Consider how we hunt for aliens today. Our telescopes listen for deliberate radio beacons or scan exoplanet atmospheres for industrial pollutants, signatures of a civilization still bound by combustion and electromagnetic communication. But a society powered by zero-point energy might communicate through quantum entanglement, transmitting information instantaneously across light years without a single radio wave. Their cities wouldn't belch greenhouse gases, they'd hum silently, drawing power from the fabric of space itself. To our instruments, their world might look no different from a pristine, uninhabited planet. The paradox isn't that they're not out there, it's that we're searching for them using the cosmic equivalent of smoke signals while they've moved on to something beyond our perception. Then there's the question of travel. The vast distances between stars make interstellar visits seem impractical, but zero-point energy changes the equation. A craft manipulating space-time wouldn't need to traverse the void at sublight speeds. It could warp space around it, arriving faster than light would in normal space. Even more intriguingly, such a vehicle might leave no detectable wake. No fiery exhaust, no heat signature, just a faint distortion in the quantum field as it passes. UFO reports often describe crafts appearing and vanishing abruptly, as if slipping between dimensions. If that's accurate, these visitors could be buzzing through our skies constantly, their presence as undetectable to our sensors as a shadow passing over a blind man's face. The silence might also be strategic. Advanced civilizations could deliberately avoid contact, not out of indifference but caution. Human history shows what happens when technologically mismatched cultures collide: conquest, exploitation, and collapse. A society capable of zero-point manipulation would wield power akin to gods compared to our nuclear engines and fossil fuels. Their equivalent of a prime directive might involve observing from a distance until we reach an ethical or technological threshold. Some abduction accounts even describe warnings about humanity's environmental recklessness, as if these beings are waiting for us to mature before initiating open contact. Or perhaps the answer is even stranger. Theoretical physicist Jacob Hack-Misra proposed the zoo hypothesis, suggesting Earth is intentionally isolated a cosmic wildlife preserve. But what if the zookeepers aren't distant overseers, but neighbors hidden in plain sight? Zero-point energy could enable cloaking so perfect alien observers might live among us undetected, their presence masked by technologies that manipulate light, gravity, and even human perception. Ancient myths from Sumer to the Andes speak of sky people who walked alongside humans before retreating. Could these legends hint at a civilization that never left but simply learned to hide more completely? The darkest possibility is that zero-point energy isn't just a tool for advancement but a filter for survival. Astrophysicist Brandon Carter's anthropic principle suggests universal constants are finely tuned for life, but what if mastering vacuum energy is the real test? Perhaps civilizations that fail to harness it implode under the weight of their own resource wars, while those who succeed transition to a state we can't yet imagine or perceive. The Great Silence wouldn't be evidence of absence, but a signpost pointing toward a frontier we've yet to cross. The Fermi paradox forces us to confront our assumptions about what alien civilizations should look like. Zero-point energy doesn't just offer a potential solution, it reframes the entire question. We're not listening in the wrong places, we're listening the wrong way. The universe might be alive with intelligences so advanced, their presence is woven into the quantum static we dismiss as background noise. Until we learn to decode that hum, the answer to "where is everybody?" might be simpler than we dare believe. They're already here, waiting for us to recognize the invisible threads binding us all to the universe's hidden energy. From the silent hum of UFOs over military bases to the sudden accelerations that defy physics, every baffling behavior aligns with the fingerprints of zero-point energy manipulation. The evidence isn't just in witness accounts, it's etched into the fabric of quantum physics itself. We've explored how the universe's vacuum isn't empty, but a seething ocean of untapped power. We've seen how crafts could theoretically ride these quantum ripples, bending space-time to achieve maneuvers that leave our best engineers speechless. The parallels are too precise to dismiss. From the eerie electromagnetic effects reported in UFO encounters to the way these objects cluster near Earth's natural energy hotspots, every clue points toward an advanced understanding of the cosmos's hidden energy grid. But this isn't just about solving a mystery, it's about glimpsing humanity's potential future. The same quantum phenomena that might power alien visitors today could one day fuel our own journey to the stars. Imagine cities lit by devices humming with the universe's baseline energy, or spacecraft surfing the quantum foam between planets. The transition won't be easy. Breakthroughs this profound never are, but the destination reshapes everything. No more energy scarcity, no more ecological trade-offs, just the quiet, limitless pulse of spacetime itself, harnessed by a species ready to take its next evolutionary step. Yet the most thrilling possibility remains. If zero-point energy is already propelling crafts through our skies, their presence forces us to reconsider our place in the cosmos. We're not just observers of the universe's mysteries, we're participants in a story far grander than we imagined. So here's the question left hanging in the air, as charged as the quantum fields we've explored. If these visitors have already mastered the energy of the vacuum, what other secrets might they be waiting for us to discover? The answers aren't just out there, they're woven into the very fabric of reality, whispering to anyone willing to listen. The next chapter of this story doesn't belong to them. It begins with you. What will we uncover when we finally learn to speak the universe's hidden language?